Hello friends, today I will discuss about vector group of three-phase transformer. Before going through this video, we can go through my channel and also do subscribe my channel and also press bell button for notification of videos to be uploaded in future. Now, before discussing about the vector group, let us discuss about the single phase transformer. This is the high voltage winding and this is the low voltage winding. Both the winding are connected in the same core for single phase transformer. Dot product represent the polarity of the induced EMF in the HV side and LV side winding. Now induced EMF, whatever be the phase in the HV side induced EMF, the phase in the induced EMF in the LV side winding will be the same. If this point represent the positive polarity, then this point should also represent the positive polarity in the LV side winding. If E1 is the induced EMF in the HV side winding, E2 is the induced EMF in the LV side winding, both the induced EMF phase of the both the induced EMF phase will be in the same phase. But in case of three-phase transformer, there are three coil. For single-phase transformer, there are only one coil. That is, one coil connected in the HV side and one coil connected in the LV side. Induced EMF is E1 in the HV side winding and induced EMF E2 is the LV side winding. But in case of three-phase transformer, there are three type of such coil connected in either in star or in delta. Similarly, in the LV side, there are three such coils connected in star and or in delta. Based on different connection, there are different vector groups comes. Now we'll discuss about the vector group. To represent the vector group of a three-phase transformer, in the AAX, capital A represent the HV side connection of the transformer. If it is a star connection, then it will be capital Y. If it is a delta connection, it will be capital D. Small a represent the LV side connection of the transformer. If it is a star connection, then it will be small y. If it is a delta connection, then it will be small d. And x represent the phase displacement based on the clock rotation. If minute needles represent the HV side winding induced EMF and our needles represent the LV side induced EMF. If LV side induced EMF lag 30 degree by HV side, then the our needle will be at 1 o'clock, that is minus 30 degree phase shift. Similarly, if the if the hour needles remain at 6 o'clock, then there will be 180 degree phase shift from HV side induced EMF to the LV side induced EMF. If again this needle, that is our needle, at 11 o'clock, then there will be phase lead in the induced EMF of LV side winding from HV side winding of 30 degree phase, that is plus 30 degree phase shift. This is how the vector group represented it down in case of three-phase transformer. Now, first we discussed about the 0 degree phase shift, that is connection of vector group Yy0. Y means the HV side is star connected, small y means LV side is again star connected, and 0 means the induced EMF in the LV side is in phase with the induced EMF in the HV side phase. So these three coils represent the HV side winding and these three coils represent the LV side winding. A1, A2 represent the R phase of the HV side winding, B1, B2 represent the Y phase of the HV side winding, and C1 C2 represent the blue phase of the HV side winding. Similarly, small a1 a2 represent the HV side winding, LV side winding, and small b1 b2 represent the LV side Y phase winding, and small c1 c2 represent the LV side blue phase winding. And now, since there is zero phase shift, there will be no phase change in induced EMF in HV side with respect to induced EMF in the LV side. Now in the HV side, we will sort A2, B2, C2 to form the start point in the HV side winding, and supply terminal is taken from A1, B1, C1. The phasor diagram represent A1, B1, C1 are the supply terminal, and A2, B2, C2 are sorted together to form the start point in the HV side. Similarly, in the LV side, sort A2, B2, C2, and the supply is taken from A1, B1, C1. You can see here A2, B2, C2 are sorted, and A1, B1, C1 are the supply or connection terminal. You can see their HV side induced EMF and LV side induced EMF are in same phase. There is no phase shift between HV side induced EMF and LV side induced EMF. That is why it is a 0 degree phase shift, and the vector group is Yy0. Now another connection, that is 180 degree phase shift of LV side induced EMF from HV side induced EMF. The vector group is Yy6. Here in case of HV side winding, the coil connection are same as that of previous, that is A2, B2 or C2 and are sorted together to form the neutral formation of the HV side star connection, and connection terminal are A1, B1, C1. These are the phasor diagram. A1, B1, C1 are the connection terminal, A2, B2, C2 are sorted. But in case of LV side winding, instead of sorting A2, B2, C2, we will sort A1, B1, C1 to form the neutral of the star connection, and connection terminal are A2, B2, C2. Here the polarity is reverse, that is A2, B2, C2 are the connection terminal, and A1, B1, C1 are sorted together to form the star point of the transformer. So you can see the induced EMF in the LV side winding is 180 degree phase shift from the induced EMF in the HV side winding. As there is 180 degree phase shift, it is a 6 o'clock. So the vector group is Yy6. Now another vector group, in here there is minus 30 degree phase shift of the LV side winding from that of the HV side winding. That is vector group is Yd1. Here again for HV side is star connected, and for HV side connection A2, B2, C2 are sorted as it was previous, and supply connection terminal are A1, B1, C1 as shown in this phasor diagram. But LV side is delta connected. Here A1, A2 are the red phase, B1, B2 are the yellow phase of the winding, and C1, C2 are the blue phase of the winding. A2 is connected with B1, and B2 is connected with C1, C2 is connected with C1, A1 to form the delta in the LV side winding, and connection terminal are A1, B1, C1. So in between A1 and B1 there exists a red phase coil. In between A1 and B1 there exists red phase coil. in between B1 and C1 there exists Y phase coil, and in between C1 and A1 there exists blue phase coil. So this is the red phase, yellow phase, blue phase. Now we'll see what is the phase shift of the LV side winding with respect to HV side induced EMF. To determine the phase shift, we'll draw the virtual neutral in the delta. If we draw the virtual neutral, this will be the neutral point, and draw a vertical line that will represent the 12 o'clock in the, or 0 o'clock in the clock rotation. And if we join this neutral with the red phase or A1 terminal or connection terminal of A1, it will be 30-degree phase shift, or it will be represent the 1 o'clock. That is, you can see the LV side induced EMF is minus 30-degree phase shift with respect to HV side induced EMF, and that is why it is called Yd1. Yd1 vector group means Y represent the HV side winding is star connected, D represent the LV side winding is the delta connected, and 1 represent the LV side winding induced EMF is 30-degree phase lag with respect to HV side induced EMF. Now another type of vector group where plus 30-degree phase shift of the LV side induced EMF with respect to HV side induced EMF. The vector group is Yd11. Now again the star side connection is same as it was previous, that is A2, B2, C2 are sorted together to form the star point of the neutral point of the star side, and A1, B1, C1 are the connection terminal. But in case of delta, instead of sorting A2 with B1, we will sort now A1 with B2 and B1 with C2 and C1 with A2, and connection terminal taken from A1, B1, C1. So connection terminal are A1, B1 and C1. You can see in between A1 and B1, in between A1 and B1 there exists Y phase of the winding. In between A1 and B1 there exists Y phase of the winding. In between A1 and C1, you see there exists red phase of the LV side winding. In between C1 and B1, there exists blue phase of the winding. So this is the red phase, this is yellow phase, and this is the blue phase of the winding. Now if you draw the virtual neutral and draw the vertical line that represent the 0 o'clock or 12 o'clock, this if we extend this virtual neutral to the A1, this represent the 11 o'clock in the clock rotation. So you can see the LV side induced EMF, LV side winding induced EMF is 30-degree phase lead with respect to HV side induced EMF, and that is why it is called Yd11. That is 11 means LV side induced EMF will be 30-degree lead with respect to HV side winding induced EMF. Another type of vector group connection where plus 150-degree phase shift of the LV side winding induced EMF with respect to HV side winding induced EMF, that is Yd7. Again HV side is star connected. The connection is same as it was previous, that is A2, B2, C2 are sorted together, and A1, B1, C1 are the connection terminal. But in case of delta, the sorted terminal was A1 with B2, B1 with C2 and C1 with A2, as that in case of Yd11. But here the connection terminal is A2, B2, C2 instead of A1, B1, C1. So there is phase shift of 180 degree for red phase, yellow phase and blue phase. So you can see in between A2 and B2, A2 are the connection terminal, there exists red phase. In between A2 and B2 there exists the red phase of the winding. In between B2 and C2, in between B2 and C2 there exists Y phase of the winding, and in between C2 and A2, in between C2 and A2 there exists the blue phase of the winding. So if you draw the virtual neutral and extend it to the A2 terminal, and this neutral is further extend to the vertical straight line, this point represents the 0 o'clock in the clock rotation, and this is the 6 o'clock, and that is why it is a 7 o'clock, that is plus 150 degree phase shift of the LV side winding induced EMF with respect to HV side in winding induced EMF. That is why it is called Yd7 vector group. Now again another type of connection, that is minus 150 degree phase shift, that is the vector group is Yd5. Again HV side connection is same that was previous, that is HV star connected and A2, B2, C2 are sorted together and connection terminal are A1, B1, C1. A1, B1, C1 are the connection terminal, A2, B2, C2 are sorted together. Now for the LV side winding, now to form the delta, A2 with B1 is sorted, B2 with C1 is sorted and C2 with A1 is sorted, and connection terminal are A2, B2, C2. So you can see in between A2 and C2, in between A2 and C2 there exists the red phase coil of the LV side winding. In between A2 and B2, in between A2 and B2 there exists the Y phase coil of the LV side winding. In between B2 and C2, in between B2 and C2 there exists the blue phase of the winding. So if I draw the virtual neutral and extend it towards the connection terminal, that is the red phase A2, and the virtual neutral is extend to the vertical line that represents the 0 o'clock, and further it is extend towards the downwards, it will represent the 6 o'clock, and it will be minus 150 degree phase shift from 0 o'clock, or it will be in clock rotation 5 o'clock. That is LV side winding induced EMF is lags 150 degree with respect to HV side induced winding induced EMF, and that is why it is called Yd5.